All right, let's jump feet first into the pretty complex world of design and construction today. We're focusing on something absolutely essential for making modern digital building projects work. The BIM Execution Plan. You might hear it called the BXP.
That's right. If you've ever wondered how these, sprawling projects manage to coordinate everything digitally, all the pipes, ducts, walls, well,
Yeah.
this document, the BXP, is basically the key.
And for our deep dive today, we're really leaning on what's become a definitive resource, especially for teams newer to this. It's the BIMForum BXP Guide version 2.00 from back in November 2020.
Hmm.
What's really important here is that this guide, it's specifically aimed at the small to mid-size market. We're talking projects generally, maybe under 5 stories or under about $150 million in cost.
Exactly. It's designed for teams who might be totally new to the whole BIM process. So our mission really is to unpack the essentials, the structure, the timing, which is critical, and the technical stuff you just have to get right in a BXP.
It's more than just a checklist then.
Oh, absolutely. Think of it as the foundational ground rules for what we call virtual design and construction, or VDC. It's essentially an agreement. It lays out the detailed plan for how models get created, what information goes in them, how it's exchanged, and everyone involved has to buy into it.
And the payoff, what's the ultimate goal?
Well, the measurable success, it really boils down to one main thing: getting effective clash detection done early. And if you do that right, ideally, you avoid clashes altogether down the line.
Okay, let's talk business for a second. For you, the listener, maybe implementing this for the first time, why invest all this effort up front? It sounds like a lot of planning.
It is effort up front, yeah.
But I'm guessing the payoff is significant.
Huge. A well-written BXP clarifies everything: who's responsible for what model, what format the files need to be in,
Hmm.
all those details.
So it's like an insurance policy against, well, against expensive mistakes caused by people just not being on the same page.
Precisely. And we see this in the survey data from the guide, actually. Something like 93% of industry folks felt a good BXP reduces the financial risk for the whole project.
Wow, 93%. That's almost unanimous. That really speaks to the need for that process rigor.
It does. And like you said, the investment is front-loaded. You're essentially creating a digital contract. It defines the geometry, the information, the timing for every single digital piece. You capture institutional memory, you build in foresight. It's all there in one place. Stops people from reinventing the wheel, or worse, making conflicting assumptions about basic things like where the model origin point is.
Okay, so the guides for teams new to BIM, can you give us a couple of really concrete examples? Who really benefits most from this sort of introductory level detail?
Sure. Think about maybe a $3 million police or fire station, small municipal project. It's pretty likely the design team is introducing these BXP concepts to the owner for the very first time. Or a classic one, a general contractor working on, say, a $20 million elementary school. They're trying to bring their specialty trades into a coordinated VDC effort. And many of those trades, historically, they haven't been the ones creating or managing the models.
That point seems really important because the industry surveys you mentioned, they show that some parts of the construction world are, well, lagging behind in adopting BIM. Right?
It's significantly lagging, yeah.
Yeah.
So the BXP becomes this crucial translation tool. It helps bring those segments up to speed, quickly, and hopefully painlessly.
And who are we talking about there? Which trades tend to need this guidance the most, according to the surveys?
Yeah, the list is pretty revealing. The top 4 identified as the least BIM-enabled were, number 1, civil and utilities.
Okay.
Second, drywall and cold-formed metal framing. Third was masonry. And fourth, roofing and exterior waterproofing.
Huh. That makes a lot of sense when you think about it. Civil and utilities, they often use completely different coordinate systems, different software like GIS.
Exactly. State plane coordinates, things like that.
Yeah.
They have to somehow mesh with the building's local model coordinates.
And the others you listed, drywall, masonry, roofing, often they're specialty subs who might have their own ways of doing things, maybe not standardized modeling practices.
Precisely. The BXP acts like the universal interpreter in that situation.
Yeah.
It forces all these different teams, maybe using different software, different internal standards, to commit to the same shared rulebook for that specific project.
And it's not just about the technical side, the file sharing and coordinates, is it? The BXP also covers things like organizational structure, who reports to whom, meeting schedules, communication protocols.
Oh, definitely.
I'd guess those non-technical parts are sometimes even more valuable.
They absolutely can be. When the survey asked people to pick the top 3 benefits of a good BXP, yes, number 1 was technical, coordination and clash detection. Makes sense.
Sure.
But numbers 2 and 3 were about expectations. defining the construction team's expectations and defining the design team's expectations. It formalizes accountability.
So if the model is like a digital contract for booking physical space,
Yeah,
then the BXP is the sort of legal agreement defining who puts what in that contract and, crucially, when they have to deliver it.
that's a great way to put it, yes.
And this emphasis on planning, on organization, it seems like it has real-world ripple effects, too, beyond just the computer screen.
It really does. Something like 71% of the survey respondents agreed that having a BXP actually improves physical construction safety on site.
71%. How does that work?
Well, the logic is pretty straightforward. A well-planned model developed early through VDC forces the team to think through sequencing, how things get built, material laydown areas, access points for workers and equipment. A pre-planned, well-organized job site is just inherently a safer job site than one where people are figuring things out on the fly.
Okay, so if this BXP carries so much weight, organizing the team, defining the tech, impacting finance, even safety, that brings up a big question. Who should actually write it? It sounds like you want your most experienced person on this.
You really do. Ideally, yeah, the BXP should be developed by the most experienced, certified, and qualified person available. In a perfect world, that's actually a knowledgeable building owner.
The owner. Why them specifically?
Because ultimately, they're the ones who care most about the building's entire life cycle, right? Long-term operation, maintenance. Those end goals should inform the BIM requirements from day one.
But let's be realistic. Many owners don't have that deep VDC expertise in-house.
That's very true. And that's exactly where you see the need for, say, a third-party BIM consultant. They act as the owner's representative. Their job is critical, making sure the owner's goals for model handoff, for facility management data, all that stuff gets correctly baked into the BXP right from the start.
I imagine the whole development strategy also shifts quite a bit depending on the project delivery method used. How does a BXP look different in, say, a super collaborative IPD project versus a traditional design bid build?
Oh, they're worlds apart. In those highly collaborative methods like integrated project delivery or design build, you typically have the owner, the designers, the main contractor, maybe key trades, all working together from the very beginning.
So they build it together?
Yeah, they develop a single, shared, combined BXP. It's built on consensus from the get-go.
Okay, contrast that with the old standard design bid build, which is still common for smaller projects.
Right. In DBB, it's often fragmented. You might have the designer's BXP, then the GC comes on board and maybe has their standard BXP, and then individual trades might even have their own modeling plans.
Sounds messy.
It can be. They all have to be reviewed, modified, somehow aligned to meet the owner's original goals. That's a major potential point of friction and confusion. And that's where that third-party consultant, if the owner has one in DVD, becomes absolutely vital for keeping that singular owner vision driving the process across all those separate documents.
That sounds like it could easily become a management nightmare if the timing isn't right. When do these ground rules absolutely have to be nailed down?
Early. You have to be early. If you wait until people actually start modeling, you've already lost time and, frankly, introduced unnecessary risk.
So how early are we talking?
Well, for lead designers who are sharing this BXP with their sub-consulting engineers and specialists, the survey showed 66%, two-thirds, said the BXP needs to be available right at the request for proposal or fee negotiation stage.
Before they even finalize the scope and fee.
Exactly. Before BIM work truly begins.
Yeah.
It means the rules for collaboration, the expected deliverables, they're already set. It defines the work effort properly from the start.
Okay, that makes sense for the design side. What about for the construction team?
Even stronger consensus there. For construction teams bidding on the work, 70 to 71% said the BXP must be available at the pre-bid meeting.
Why is so critical at pre-bid?
Think about it. If trades are being asked to bid on a project that requires a significant VDC coordination effort, they absolutely need to know what they're signing up for. What level of development LOD are they expected to model to? What's the schedule for model submissions? What are the rules? Bidding blind on coordination work is just asking for change orders and disputes later.
Got it. So the BXP defines the process, the timing. It must also define the people running that process, right? What about minimum requirements for the BIM team members themselves?
Absolutely. The guide stresses that the BXP must spell out minimum requirements for both the key roles, typically the BIM manager, and the individual modelers. And actually, it should even specify minimum specs for the computer hardware they need to use.
Hardware too, interesting.
Yeah, because you can't have someone trying to manage a massive coordinated model on an underpowered laptop. It just won't work. And certifications, especially for the BIM manager role, are seen as highly valuable. They provide a baseline assurance of knowledge.
Any specific examples?
For instance, the BXP might require the BIM manager to hold something like the AGC Certificate of Management in BIM, the CMBIM. It ensures the person leading the VDC effort has proven knowledge at everything from modeling standards to software interoperability to contract language. All the stuff that's essential for actually enforcing the BSP throughout the project.
Okay, we've covered the who and the when, the organization, the timing. Now let's dig into the actual contract language, the technical details that make sure every digital file speaks the same language. The quality control part, things like project info and milestones seem pretty straightforward. Let's get into the real technical nuts and bolts. Where do you start?
You have to start with coordinates. Has to be coordinates. This is probably the single most critical technical decision you make early on.
Why so critical?
Because if the coordinates are wrong, everything that comes after is wrong too. Every clash detection run, every dimension pulled, every piece fabricated based on the model, it'll all be off.
Okay, so what's the standard practice for setting up that local coordinate system, especially for teams who might be new to this whole process?
Right. The BXP must clearly, unambiguously define the local relative building XYZ origin point. The common practice, the standard, is to tie that origin to a known permanent physical location on site. Usually it's the intersection of the column grids, typically the southwestmost intersection.
Southwest corner grid intersection, okay.
But then you apply a large offset to that physical point. You shift the digital origin maybe 100 feet, 1,000 feet, even 10,000 feet away from that grid intersection.
Hang on, why the big offset? That sounds kind of arbitrary. Why not just use the grid intersection itself as 0, 0, 0?
It seems arbitrary, but it's actually quite strategic. The offset ensures that your entire building, all the structure, all the geometry, falls within a positive XY coordinate system in the digital model.
Ah, so you avoid negative coordinate numbers.
Exactly. It eliminates negative numbers, which historically, and even sometimes today, can cause glitches or calculation issues when you're transferring files between different software platforms or running certain analyses. It just simplifies things and reduces potential errors.
Smart. Okay, so we have the local building origin set. Is that it for coordinates?
Not quite. That's the foundation, but the BXP needs to document the relationships between 5 key coordinate systems. We just talked about the building local system. But you also need to consider the object system that's for specific equipment or component references. Then there's the campus or site system, if it's part of a larger complex. And then the 2 big ones that bridge to the outside world, state plane and GPS.
Okay, let's quickly define state plane, because I agree, that's probably the one most teams new to BIM might gloss over, but it sounds crucial.
It is crucial. State plane is the system that civil engineers, surveyors, and often public utility companies rely on. It's a government-established, legally defined, absolute coordinate system tied to real-world geography.
Not relative like the building system.
Correct. It's absolute. The BXP's job is to clearly define how that absolute real-world system connects to your building's local, relative, and somewhat arbitrary system that we just set up with the offset. Get that wrong, and the incoming water main might be shown 5 miles away from your building's foundation in the coordinated model. Big problem.
Understood. That clarity is absolutely priceless. Okay, moving on from coordinates. How do we break down the project itself for manageable coordination? We hear terms like levels and zones.
Right. Levels are usually pretty simple, typically defined from the finished floor elevation of one level to the finished floor of the level above it. Standard architectural practice.
Okay.
But for coordination meetings, trying to review an entire floor level at once can be overwhelming, especially in larger buildings. So we divide the levels into zones.
Zones. And what defines a zone?
A zone is basically a manageable chunk of the building. It often corresponds to logical architectural plan areas, maybe areas defined by expansion joints or major corridors. Size-wise, they often end up being around, say, 30,000 to maybe 36,000 square feet.
Is there a reason for that specific size range?
Yeah, it's somewhat strategic. That size represents roughly the maximal amount of complex model information. All the layered piping, HVAC ducts, structure, electrical conduits that a VDC coordinator can effectively manage and review on screen, and that a team can realistically analyze and resolve clashes within during a typical 1 to 2 hour coordination meeting.
Ah, so it makes the meetings productive.
Exactly. It creates measurable, digestible chunks of work. The team can actually achieve a resolution on the issues within that zone in one sitting, rather than getting bogged down trying to tackle the entire floor plate at once.
Makes sense. Speaking of measurable definitions, let's talk about level of development, or LOD. The BXP relies heavily on LOD definitions, right? To specify how much information, how much detail is in a model element at different stages.
Yes, LOD is fundamental for communication. It's a standardized way to convey how much reliance you can place on a particular model element at a particular time. Is it just a conceptual placeholder, or is it detailed enough for fabrication?
And it ranges from, what, LOD 100 up to maybe LOD 400 or 500?
Generally, yes. LOD 100 is conceptual massing. LOD 200 is approximate geometry. LOD 300 is precise geometry, think typical design intent. LOD 400 is fabrication-level detail. These definitions ensure everyone knows the level of accuracy and detail they're either receiving from others or are responsible for providing themselves. But for teams doing serious clash detection and trade coordination, LOD 350 is really the magic number.
LOD 350. Tell us why that specific level is so critical. It sounds like it bridges design and actual construction.
It absolutely does. LOD 350 was actually a later but really crucial addition to the official BIMForum LOD specification. It was ratified back in 2013 specifically to address the information needed for effective trade coordination.
What does it add beyond LOD 300?
It's the level that requires modeling not just the main element like a duct, but also its interfaces, its supports, and its connections needed to coordinate that element with all the adjacent building systems.
So things like hangers, bracing, clearances.
Exactly. It forces the modeling of hanger rods, seismic bracing, connection flanges, access points, all the stuff that turns a designer's schematic intent into a spatially accurate, buildable object. Without reaching LOD 350 for the major systems, you can't really coordinate the space effectively and avoid clashes during construction.
Okay, one final technical piece. You mentioned modeling things that aren't physically there. Clearances. Why does the BXP need to demand modeling of essentially empty space?
Right, because not everything you need to coordinate in a model is a physical pipe or beam. You have critical clearance spaces. Think about maintenance access for equipment, pull space needed in front of electrical panels, code-required clearances around certain machinery, or even the zone needed to remove and replace a large piece of equipment like a VAV box years down the road.
And how do you model empty space?
We typically model these required clearances as geometric objects, often simple boxes or cylinders, but we make them transparent or put them on a specific non-plotting layer. If you don't explicitly model that required clearance zone, that reserved buffer space, then your clash detection software won't flag it when, say, a plumber runs a pipe right through the area needed to service an air handler filter bank.
And you won't find out until it's built.
Yeah, exactly. And you're guaranteed a major headache, a costly rework, or maybe even a system that can't be properly maintained later on because someone encroached on that reserved space during coordination. Modeling clearances prevents that. Hashtag outro. So we kind of tie this all together thinking about the bigger trend of VDC adoption. This document, the BIM Execution Plan, it really is the foundation for success, especially like the guide focuses on for smaller firms maybe taking their first real steps into coordinated BIM. It takes these sometimes abstract ideas like collaboration and accountability and turns them into defined, measurable metrics. Specific LOD requirements, shared coordinate systems everyone agrees on, clear milestones for delivery. It effectively creates that digital contract for every square foot of the building.
Yeah, by getting everyone to agree on those rules up front, by institutionalizing that planning process early, the BXP becomes this key driver for reducing risk and ultimately improving efficiency in how we design and build today. Okay, now the BIMForum Task Force, the group that actually created this guide we've been discussing, they make a strong recommendation. They suggest that smaller companies, the ones maybe new to BIM, should evaluate their use of outside third-party BIM support every single year.
That's an interesting point.
It is. And their reasoning is important. They say the long-term goal for any business involved in designing, constructing, or operating buildings must be to develop its own internal VDC capabilities. Because these expanded BIM uses, they're rapidly becoming the standard of care in the industry. So that leaves a pretty important question for you, the listener, to think about. How are you actively building that permanent internal VDC capability within your own firm today?